Hi there, Jeters. We're back. And we're going to do maybe a shorter episode. We'll see. But I saw this Instagram today, and I loved it so much. I felt the need to have us watch it together. So without further ado, I'm going to mute myself, and we're going to listen to what this gentleman has to say. I strongly encourage all of you to pay close attention. I think that wiser words have rarely been spoken.
You don't become confident by thinking positive. You become confident by doing hard shit and watching yourself not quit. Most people think confidence is a mindset. It's not. It's evidence. You can journal, you can visualize, you can manifest. But if you keep backing down from the things that scare you, your subconscious knows that you're full of shit. That voice in my head didn't change because I started talking nicer to it. It changed when I gave it proof that I'm no longer who I used to be. I've built confidence by doing the hard things over and over until my nervous system started to believe I can do hard things. I don't run. I do follow through. Confidence isn't built in comfort. It's built through evidence. Do this today. Pick one thing that you've been avoiding. The workout, the sales call, the post that you're scared to publish, the announcement that you're scared to make. Do it right now. Not because you feel ready, but because the old version of you needs to die. Confidence doesn't come from hype. It comes from history. Develop a history that proves to yourself that you do hard things. You don't become confident by thinking positive. You become confident by doing hard shit and watching yourself not quit. Most people think confidence is a mindset. It's not. It's evidence. You can journal, you can visualize, you can manifest. But if you keep backing down from the things that scare you, your subconscious knows that you're full of shit. That voice in my head didn't change because I started talking nicer to it. It changed when I gave it proof that I'm no longer who I used to be. I've built confidence by doing the hard things over and over until my nervous system started to believe I can do hard things. I don't run. I do follow through. Confidence isn't built in comfort. It's built through evidence. Do this today. Pick one thing that you've been avoiding. The workout, the sales call, the post that you're scared to publish, the announcement that you're scared to make. Do it right now. Not because you feel ready, but because the old version of you needs to die. Confidence doesn't come from hype. It comes from history.
Confidence doesn't come from hype. It comes from history. It comes from evidence. And as I've said many times in the past on this channel, you have to decide that you are world class, and then you must prove it to yourself every day. The deciding that you're world class is a mindset. It's a mindset that you have confidence in yourself to be world class, to become world class. And let's just be honest. If you're telling yourself this right now, there's a good chance that you are not yet world class. And this is where the second part comes in, is then you start to prove it to yourself every day, just like what he's talking about. You don't develop this unwavering confidence that you can teach at this university, or you can create your own VC-backed startup, or you can be a world-class programmer, or you can be an Olympian, or an astronaut, or a best-selling author. None of those things happen purely from thinking positive thoughts. The positive thoughts are the first step. You do need to have unwavering belief in yourself, but that alone is not going to get you there. You then have to put in the reps. You have to do this over and over and over again. There are no shortcuts. There are no shortcuts. You have to put in your 10,000 hours, wherever that is. It's in here somewhere. And it's super important that you do this. This is you reproving it to yourself over and over and over again. And I also want to say, and he mentions this in his Insta, is that most of the reason why we will back down from things and not try them and make excuses about how we're not ready, we need more time to prepare, or we're not qualified, we need another year. And sometimes that's true. Sometimes like when I was studying for the GRE, right? I didn't go take the GRE right away, but I did start working toward the GRE immediately. And I took those practice exams starting on day one. Day one, I took one. I want to know where I stood, and I did abysmally. But then I wrote that down. I tracked that, and then that was my baseline. And then I studied, I worked, I took another practice exam a week later. The scores were improving slowly, but it was getting better. Continued to work, took another practice exam a week later. Scores continue to improve. What's happening is that I am seeing this in my head. I am doing this every day. And then because of this and this effort, this view that I have is starting to manifest because I can see the evidence. I see the evidence of my achievements, the growth that I'm making, and what starts out as a little bit of a lie. When you say that you're world class and you know that you're not, slowly what happens is you start to become world class. You start to be the person that you want to be. And so it really is a combination of these two things, minimally. I do believe you have to have the mindset, and you don't want negativity. You're telling yourself that you're not good enough, that you're never going to achieve greatness, that you're never ready, and so on and so forth. This is just talk that people that fail talk about. Oh, I'm not a salesperson. Oh, I'm not a programmer. Oh, I'm not an actor. Oh, I'm not a runner. Right? Sure. Like at one point when I decided to switch my research from being parallel computing to machine learning, I just started doing it and said, well, I guess I'm going to start doing machine learning research. And some of my research colleagues came to me and they said, but Justin, this is before I was Goju, Justin, you don't do research in machine learning. You do research in parallel computing and in systems and in programming languages. You've never written a machine learning paper before in your life. And they were right. And what I reminded them was there was a time in my life where I didn't write any parallel computing papers either, or programming languages papers, or systems papers. There was a time in my life when I wasn't publishing any papers. Did that stop me from starting to investigate those areas and become a published author? No. Because I know the process is that in order to become an expert, I must first start on the path of being a beginner. That's how you become an expert. No one shows up and is an expert from day one. And I'm going to give you a short example here because I saw this online and I thought that it was quite fascinating. And I can almost guarantee that most of you, when you see this at first, you will not understand this. But by the time I finish explaining it, all of you will. And it's an example of that. If you believe that you cannot do something and you let the fear of this thing stop you from doing that thing, you will never do that thing. That's how life works. But if you look at the thing that's scary and then you decide in your head that you're going to try to do this thing anyway, even though you don't know what you're doing, it's amazing how fast you can actually learn how to do the scary thing. And then the scary thing is actually no longer scary at all. And now you know something and you're no longer like a full beginner. Now maybe you're at 1% efficiency. So we're going to do a quick look on looking at a shell bomb. Here we go. This is what I want to look at. I want to look at this shell bomb. Okay. This is the code I want us to look at. And I'm going to drop it into Visual Studio. And I don't even know if this works, but it works in, yeah, it kind of works. Yeah, this is the shortcut key to make all the text bigger or smaller in Microsoft products. Again, if you know the hacks, you can do things pretty well. I'm going to comment this out just so it stops giving me squigglies. And then we're going to look at this code. And so the hack is it's Shift Control and then the greater than sign will make it bigger, and the less than sign will make it smaller. Just like that. Control Shift. Here, I'll actually even write it down so we all have it. I think that this works in almost all Microsoft products. I use it in Word, PowerPoint, Excel, several other things. So increase text, we'll say font size, Control plus Shift plus greater than, decrease font size, Control plus Shift plus less than. You have to, and what I mean by plus is you have to hold these. So you have to hold down Control, Shift, and then that. And then what I usually do is I'll hold down Control and Shift, and then I'll press the greater than key. That'll do it once, and then as many times as you need to do it. So over here, I'll start to make it smaller. So I'm making it smaller, 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 smaller. Then we get to a point to where like, okay, this is too small. Right? And then I'll make it bigger. Bigger, 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 bigger. Okay, cool. So even if you know about this shell bomb script, now maybe you've learned how to increase the font size in Microsoft products. Cool. So we are going back to some of our core principles on GTT, which is this guy. Never stop growing. Never stop learning. And also, as he was saying before, the evidence part is really important to convincing yourself, because your subconscious knows when you're lying, when you're faking. The rest of the world may not, but your subconscious does. And so if you're data driven and you have data that shows that you're developing these skills, then your subconscious will see that data. It will see that evidence, and it will start to become conditioned that you don't need to run from these things. You can actually achieve these things. So for example, I didn't start teaching from day one at this place. This is, I think, potentially far too scary, too high of a bar, perhaps. Does that mean that I decided I'm not going to teach at all? No. What I did is I put in the time. I believed that I was world class, but I started to put in the time in places that were not at this level. In fact, this was never even really the goal. Not for the first maybe 40 years of my life. It was not even on the radar. Okay, maybe the first 35 years of my life. But the first place I started teaching was, it was probably Colorado State University. I was a TA, and I started running mini lectures in Computer Science 101, Introduction to Programming. That's where I first started teaching. And I had these mini lectures, and there'd be like 80 freshmen, sophomore students, and I did that for 3 years. That gave me the confidence to then start teaching an industry. And I started running classes to teach people how to do object-oriented programming. at one of the first companies I worked for out of school, which was Quark. And then I continued to do this when I went and I worked in defense contracting. When I worked at Raytheon, I was teaching the engineers there. I went to India for a few weeks and I taught object-oriented programming to a few hundred of my Indian developer colleagues. Then I started to do teaching of machine learning when I was in grad school. I continued to do that as an adjunct professor at CU Boulder after I graduated with my doctorate. And then from there, I started teaching these things Intel Labs, a couple invited lectures at places like MIT. I got my adjunct professorship at University of Pennsylvania and started to I mostly did research with PhD students there, but I did give guest symposiums and in some of the courses at Penn, and then did similar things at Berkeley and including at this university. And then after I was doing that for 20 years, then I started to teach at this place. So the point is that, like this guy is saying, it doesn't happen overnight. You don't just wake up one morning and say, oh, I'm going to be a teacher or a professor at one of the world's best universities. Just watch me do it. Okay, I believe you, but that's going to take time. It's going to take a lot of effort. It's not something that you just decide like you're going to go to the grocery store and then all these things happen. It's going to take a huge amount of work. But that work will give you the evidence to allow you to level up. And through that, you can achieve these things. But you can't do it without the work. You've got to do the work. So, a simple example of that is this code. All right. My guess is that very few people watching this channel have any idea what this code is doing. This code is going to create essentially a shell bomb script that will take down pretty much any computer that you run it on, including your own. What's also really interesting about this is that if the computer is running Linux, or it's running Mac OS, which is basically running on top of OpenBSD kernel, or if it's running Unix, this stuff will run almost natively from the command line. You can literally type this in, and if you have the right shell scripting language, like Bash, I think, or C shell, I think that it will accept this as a valid program, and then you will shell bomb your machine, which basically means at some point this script, which looks pretty harmless, and it's just a whole bunch of symbols, which probably seems very strange and like tricky and confusing, and I'll show you in a second, it's not at all. It's actually extremely simple, that this will take down your machine. You'll have to reboot your machine. Okay, so this is an example of what it looks like when you decide that you're going to be world class, and then you show up, put in the effort, and then you learn things. You do the things that are necessary, so you generate the evidence that is necessary to convince your mind that you are going to become amazing. So in this particular case, you may think, I don't know anything about security for programming, so I can't possibly be like a security expert in programming. Well, I'm going to teach you right now. And the truth is, many of the folks that are in security, many of whom I'm very good friends with, and in fact, I've done quite a bit of security analysis myself over the last 20 years, and it's quite interesting. So, but many of the folks that I've worked with in this space, they have told me this is how they started, is they just started learning about all the various ways to do security hacks. So let's dissect this and try to understand. Now, again, the hope is that at the beginning of this, at the timestamp of exactly 20 minutes, you know nothing about this. And hopefully over the next 10 minutes, you will know this so well that you will be able to explain it to someone else and exactly why it will take a machine down. This stuff over here is just the comment. It has nothing to do with the script. The script starts here. All right. What we're going to do in this is we are going to first create a function. And that is what we're doing with these open and close parens. This is creating a function, and the function name is colon. Why did we pick colon? It's just arbitrary. It's an available character, and the truth is it probably makes the code even more obfuscated and curious in terms of what is it doing. But we don't have to call it colon. We can call it something else. So let's do that. Let's call this shell bomb. Okay, shell bomb. Shell bomb. Shell bomb. Shell bomb. All right. It's shell bomb everywhere now. And part of the reason why we don't call it shell bomb initially is we want it to be more covert. We want it to be harder to understand and have people not know that this is actually a shell bomb that's going to take your machine down. If you copy this line of code to someone's system and you are about to hit enter, they might say, wait a second, are you trying to shell bomb my terminal? And then you would say, yes, in fact, that is what I'm trying to do. So this is why we call it the function name is the colon. It's also very short. And on top of that, security folks, specifically those that are trying to break into machines, will often obfuscate their code in a format that makes it nearly unreadable. It's almost like as bad as some of the theoretical mathematicians. Sorry, guys, but you know, I feel like they're learning from you. So if you guys gave like better names of things, I think they might too. So let's look at this first example because this will be easier to understand. You create a function called shell bomb. Now inside of the curly braces is the actual body of the function, right? This is the function here. That's it. Okay. Now the shell bomb function is going to call itself recursively. It calls itself here. And then this is the pipe operator, which basically says, then I want you to pipe the output, I think, from this thing into this other shell bomb function that I want you to call. But this one I want you to call in the background. This is what the ampersand means. Now, this one is super important because it's the ampersand and running in the background that allows it to run basically rogue and take over your machine. If you didn't run this in the background, basically what would happen, I think, I haven't tried this, is it would lock up your terminal. And then if you just control C it, you would kill it. And it would feel like your terminal's unusable for a moment. And it would be. But then once you close the terminal or you control X or control C it, you're going to get your machine back. But when you run it in the background, the beauty of the background is the background processes don't have to wait to be run serially. They can just run wherever, however they want. So this part is critical that this happens. Okay. Then after we have all this done, what we've done is we've defined this function. We created this function called shell bomb. We've implemented it, that it calls itself, and then it pipes its output to calling itself, which is run in the background. And then we end the function, and the semicolon means that part's done. Then we invoke the function, the shell bomb function. This is what triggers the invocation of the code that we wrote here. So without this last piece, there is no triggering of the shell bomb. So essentially, if you deleted this, you would have created a function that you could call, but you don't call it, and so it's not shell bombing anything until you call it. And in some cases, maybe all you want to do is just add this to the shell space and call it whatever you want. Like that's what I think more sophisticated hackers would do, is they would somehow embed this into the system and in its active memory. And then when they were ready to do something super nefarious, they would then invoke it, probably remotely, at a very specific time, which then would guarantee to take down all the machines. And then when those machines are down, then they can do pretty nefarious stuff. Okay. So I'm teaching you probably far more things about how to do nefarious stuff. But the upside of this is that you're also learning how to look for these things and to understand how some of these security things happen so you can avoid making these mistakes. In fact, I've actually taken machines down myself. I think one time I was writing Flash and I had a recursive call in one of my functions to get some answer, and it didn't terminate properly, and I took the whole machine down. I basically shell bombed myself accidentally. And so when I see this as their example of the shell bomb, and I see that they're doing it by calling itself recursively, I think, oh yeah, I've done that. This is actually pretty effective. So I immediately think, these guys are pretty sophisticated. This works. Cool. Now we can go back to the original code and just see that in all the cases where shell bomb exists, we're just using the colon character because it's shorter and it's strange. And it has maybe this appearance of like, yeah, I don't know, this isn't really like bad stuff. It just looks like a whole bunch of, somebody just typed a whole bunch of special characters and this means nothing. But in fact, it has very precise meaning. And I actually do think that once you change the function name to a name that is meaningful, it's like all the other special characters start to become super clear. Like, for example, I don't know that you can create a function that overloads pipe. Maybe you can. I don't know. I don't know if you can create a function that overloads the background operator, which is the ampersand. Also, I don't know if you can overload the semicolon, which is an indication of the operation that you had previously concluding. So then you can conjoin it with additional operations. Maybe you can. Maybe you can't. I don't know. So part of the reason why I think they're picking colon rather than some of these other ones is that I think colon is something you can overload. Well, in this case, clearly for certain shells, you can. So now, what we just did is we took an example of pretty obfuscated code. Many of us, I suspect, had no idea what this code did or could even syntactically dissect it in a meaningful way before we started. It might have been just all gobbledygook. But then we had belief in ourselves that we could learn and put in the work and understand this. And now, less than 10 minutes later, I think all of us, or many of us, likely can understand this to the level of not only understanding what this does, but also how it does it, and then potentially to explain it in such a clear way so other people can understand. I think that that's probably possible just from us spending the last 10 minutes doing a deep dive on this. And also, as we've discussed before, this is all basic stuff. When you know about programming, and if you have any experience in shell commands, you know that like these parens like this tend to indicate a function. The curly braces tend to indicate that this is going to be the beginning and the ending of a function. The semicolon means this is the end of an operation. Calling this thing indicates that you're calling the function in all of these. The pipe operation means that you're just piping things forward, so it acts like a sequence of operations. And then the ampersand means run this in the background. So these are all basic things. And if you don't have background in Unix, Linux, shell scripting, this type of thing, this might be a little harder. But again, there's nothing super magical going on here. It just has an appearance of being super magical when you first look at it. But when you start to dissect it, one character at a time, I think it actually becomes fairly easy. And to be honest, when I saw this code snippet on Instagram a couple days ago, I first looked at it and he was saying, this is a shell bomb and I'm going to show you how it works. I was like, I have no idea what this code is. And then as he started to explain it, he was like, well, colon is the function. I was like, oh, colon's the function. Okay, well, hold on. So then that means this is the function parameters. There are none. This is going to be the function body. And then this semicolon means end this. And then you're going to invoke it here. Then I was like, oh, okay. And so you're going to recursively call the colon function here. You're then going to pipe it. And then this is going to invoke this in the background. That's immediately like, once I had that one detail, because again, I've done things with shell scripting, I was able to speculate with some degree of accuracy on what this is actually doing once I got like a single hint. Now, for those of you who don't have backgrounds in shell scripting, which could be many of you, well, now you do. Now you know a few things. You know that generally speaking, the semicolon is the operator that allows you to run operations one after another. You know that the ampersand is generally the character that you use to invoke something to run in the background. And you know what the pipe operator is, that you use this to essentially pipe the output of this thing as input into this thing. There you go. You've learned some of the core basics. You learned how to shell bomb by doing this, but you also learned the general structure of other operators that are more specific to general use in shell scripting. And these operators, the pipe, the semicolon, the ampersand, these are generally consistent operators for almost all of the shell scripting systems that I'm aware of. So if you're using Unix or Linux or OpenBSD, I think you generally have these things predefined. You would have to like overload them and change them to be something else to get them to have behavior that's not what's discussed in this shell bomb script. And so now, not only did you learn how to do a shell bomb, you have learned some of the basics of shell scripting and how to work with Unix or Linux shells, just like that, and all in the course of 13 minutes. So when we go back to this situation where we want to decide that we're world class, but we have to prove it to ourselves. This is an example of proving it to ourselves, that we say, look, I can learn these security things. So then what do? Every day you find things like this and you learn about how they work. You force yourself to become the thing that you're trying to become. You don't allow yourself to simply say, I'm amazing, I'm going to be fantastic, and then that's all you do. You have to get the evidence. You have to build up an entire arsenal of things like this to where you have the ability now, not me, to where you can take an example like this and you know it so well, you can rewrite it live and still explain it in a nearly flawless way. I'm talking about you, not me. So other people understand. And when you can do that, this demonstrates a degree of mastery, that now you don't just know the basics. Now you're starting to get to the point to where you are mastering the basics. And once you master the basics, now you're dangerous. So yeah, let's get dangerous. And let's put in the time. And let's not allow fear to hold us back. And let's prove it to ourselves every day that we're world class and generate an abundance of evidence.